Hi there, welcome back to Go Figure School of Mathematics. Today we're on lesson 65 of Saxon Algebra Half, proportions with mixed numbers and using proportions with similar triangles. Please give this video a like and subscribe to the channel. Here's a warm-up problem to start with. Pause the video and then press play when you're ready to check your answer. Okay, so here we have a conditional proportion. We want to solve for x. So what we need to do is cross multiply. So this would look like 1/5 times x equals 5 times 3/10. And then when we do that, we're going to get, we can do some cancellation here. We can factor out a 5 from these. And then we'll get 3/2. And our 1/5 times x stays the same here. And then to isolate x, to get x by itself, we need to multiply both sides of our fraction by, or both sides of our equation by 5/1. And so these will cancel out and we're just left with x equals 3 times 5 is 15 over 2 times 1, 2. So x equals 15/2. All right, our learning objectives today are to solve conditional proportions that contain mixed numbers. And then we're going to define similar triangles and then use proportions with similar triangles. So for proportions with mixed numbers, all we need to do is convert our mixed numbers to improper fractions. And then we would go ahead and solve using the method for conditional proportions that we've already learned and that we just did in our warm-up. So let's do an example. Here we have a mixed number in our proportion. So what we want to do is convert that to an improper fraction first. So this would be 7/2. And then we're going to put that over 5. And it is equal to x/8. And then we need to go ahead and cross multiply. So we would multiply there, multiply there. So then our next step would show 5x, 5 times x equals 7/2 times 8. And we can think of that as 8/1. And then there's some cancellation we can do there. So let's cancel out a 2 from there. That leaves 1. And that would leave 4 here. And now we have 5x equals 7 times 4 is 28. And it's over 1. So I'll just leave that as 28. Then our next step to get x by itself would just be to divide by 5 here. So that would leave us with x. And then what we do to one side, we need to do to the other. So 28/5. And here's another example where we have mixed numbers on both sides of our proportion. So again, we need to convert both of those mixed numbers to improper fractions. So this first one would be 4 times 1 is 4, plus 3 is 7. So 7/4 over 6 equals x over 7/2. And now we can cross multiply. So we'll have 7/4 times 7/2. And that will be equal to 6 times x. And there's no cancellation we can do there. So let's just multiply that. We get 49/8 equals 6x. And to solve for x, we need to divide by 6. So since we have a fraction over here, it might actually be better to multiply by the reciprocal. So remember, 6 is the same as 6/1. So we could actually multiply this by 1/6, the reciprocal. Multiply our other side by 1/6. And there's no cancellation that we can do there. So then we're left with 49 over 48 equals x. And there we go. Okay, now using proportions with similar triangles. So similar triangles are two triangles that have angles with equal measures. Basically, they are the same shape, but they're just a different size. So we can show that we have equal measures on our angles by using these tick marks. So here's a symbol for an angle, and then we have one tick mark there. That corresponds to this angle with one tick mark. So we know that the measure of those angles are the same. So here we have 2 tick marks and 2 tick marks. Those angles are the same. And here's 3 tick marks, 3 tick marks. Those angles are the same. So these are similar triangles. And then the corresponding sides are the sides opposite the angles of equal measure. So like opposite of this angle here is the side that is 12. Opposite this same angle is the measure 6. So that means that these sides are corresponding sides. The 12 and the 6 are corresponding sides. And then, so I can show this on here. The 14 and 7 are corresponding sides, and the 16 and 8 are corresponding sides. So if we wrote these out with a proportion, so the corresponding side 14 to 7, it's equal to the other corresponding side, so 16 to 8, and it is also equal to 12 over 6. And if you reduced each of these fractions, you would notice that they all reduce to 2. So the sides are in the same proportion to each other when you have similar triangles. So we can use our knowledge of proportions to find missing lengths of a triangle if we have missing lengths. So let's look at an example. So here we have similar triangles. If you look at the angles, you can tell that they have all the same angle measures. And so it's a similar triangles. We have 2 unknown sides, A and B here. So we can use what we know about proportions. We know that this corresponding side, 10, corresponds to 12. So I'm going to write that as a proportion, 10 to 12. And then I'm going to set it equal to one of the other ones that I'm trying to figure out. So 6 would be on this triangle, and that corresponds to side A of the other triangle. And so you see now we have a proportion that we can solve for A. So let's cross multiply. We get 10A equals 12 times 6 is 72. And I'm just noticing this. We could have reduced this fraction up front to 5 over 6. Reduce that right away just to make it simpler. But regardless, we should end up with the same answer. So and now to solve for A, we can divide by 10 on both sides. So A would be 72 over 10. And we can reduce that if we factor out a 2 from each of those numbers. So 72 divided by 2 is 36, and 10 divided by 2 is 5. So there's our answer. Side A is 36/5, which is a little bit over 7. It would be, if we converted that back to a mixed number, that would be 7 1/5. And then to find side B, we can do the exact same thing. So we're going to use the 2 sides that we know, the 2 corresponding sides that we know, 10 over 12, and set that equal to 11 over B, because those are corresponding sides. And then on this one, I will reduce that first. So let's reduce that to 5 over 6. Set it equal to 11 over B. And I'm going to use a capital B so it doesn't get confused with our 6 there. And then we cross multiply. So 5B equals 11 times 6. And then to solve for b, we need to divide by 5 on both sides. So b equals 66 over 5. If we put that into a mixed number format, that would be 13 and 1/5, which makes sense when you're looking at all the numbers here on the triangles. And what you want to be sure that you don't do is confuse the order of your proportion. So we did 10 to 12. So I had 10 in my numerator, 12 in my denominator. We don't want to then make that equal to a over 6 because that wouldn't be proportional then. You want to, if you started with this smaller triangle in your proportion, you want to use the same smaller triangle when you're making your proportion on the other side of your equation. So you want to do 10 to 12 is the same as 10 or 6 to a. Just make sure you're keeping that in order, otherwise you'll end up with a different answer. So here are your practice problems. Go ahead and pause the video and solve these on your own. Press play when you're ready to check your answers. Okay, first one here, we have some mixed numbers that we need to convert to improper fractions. So this first one, we're going to get 7/4 over 2/3 equals 21/4 over x. And now we can cross multiply. So we'll have 7/4 x equals 21 over 4 times 2/3. And then we can do some cancellation here with the 21 and 3. And also between the 4 and the 2. And then we have 7/4 x equals 7 over 2 when we simplify that. And then we need to divide both sides, or actually multiply both sides by the reciprocal of 7/4. So multiply both sides by 4 over 7. And when we do that, we'll get x equals, so I'll do this, multiply by 4 over 7 here. We can do some cancellation there. Those both turn into 1s, and then cancellation here. It turns into a 2. So x would then equal 2. All right, next one. Converting our mixed numbers to improper fractions. We have 13 over 4 divided by p equals 12, 13, 13 over 6 divided by 30, 32 tenths. And maybe this is another one where you could have reduced first. You could have reduced the 2 tenths to 1/5 and then continued solving. Then we can cross multiply. So we'll have 13 over 4 times 32 over 10. Sure, there's a times there. Equals 13 over 6 times p. Okay, and we can do some cancellation right there with the 4 and the 32. And then we can cancel between the 8 and the 10. We can factor out a 2. So that's actually 4 there. And this will be 5. Okay, now if we simplify, 13 times 4 is 52. And then that's over 5 equals 13 over 6 times p. To solve for p, we need to multiply both sides by 6 over 13. Multiply by the reciprocal. What I do to one side, we got to do to the other. Okay, and then we can do some cancellation here between the 13 and the 52. we're left with 6 times 4. I'll write it up over here. We got 24 over 5 equals P. So there we go. All right, and here's our two similar triangles. We want to find M and P. So let's look at the proportion, the corresponding sides that we know, 5 and 4. So 5 corresponds to 4. And we can set that equal to 9 over M. Again, be sure that you're doing that in the right order. You don't want it to be M over 9 if you wrote 5 over 4 here. You could always go the other way and say 4 corresponds to 5 as M corresponds to 9. So you could flip both of them over and still get the right answer. So now we can cross multiply. 5M equals 9 times 4 is 36. Divide both sides by 5. We get M equals 36 over 5, which as a mixed number would be 7 and 1/5. Okay, and then let's solve for P now. I'm going to erase this and do P. So now 5 over 4 is proportionate to 7 over P. Okay, then we cross multiply, so 5P equals 28. Divide both sides by 5, we get P equals 28 over 5. And then if we converted that back to a mixed number, you would get 5 and 3/5. So in summary, we want to write our mixed numbers as improper fractions when solving conditional proportions. And with similar triangles, we're going to use our proportions to solve for missing side lengths. And again, be sure to identify the corresponding sides when you are looking at your triangles. That's all for today. So here is your problem set from lesson 65. And if you have any questions about this lesson or assignment, just put them in the comments below. And don't forget to like and subscribe. Thanks. Have a nice day, and we'll see you next time.